Here is a quick demonstration of text-to-image using AI. First, select how many images you want the AI to generate. Then select image dimensions. Then give a description of what the image you want the AI to generate. Here is our quick description example. Then we click Generate. This not bad at all, using just one line of description. Here is the image we generated for the thumbnail. Now let's just talk about how AI, or artificial intelligence, works. In the blink of an eye, artificial intelligence has gone from science fiction to a key player in our daily lives. This rapid growth isn't slowing down. In fact, it's projected to skyrocket in the coming years. Understanding AI and its inner workings is no longer a luxury, but a necessity in our digitally driven world. So let's unravel the mystery of AI together. Artificial intelligence, or AI, is the development of computer systems that can perform tasks that typically require human intelligence. It's like teaching a computer to think, learn, and make decisions just like us humans do. The ultimate aim of AI is to create a machine that's as smart, adaptable, and capable as us, if not more. There are two types of AI we talk about. First, there's narrow or weak AI, which is designed and trained for a specific task. Think of Siri or Alexa. They're great at what they do, but ask them to do something outside their programming, and they're stumped. The second type is general or strong AI. Now this is the real deal. It's a more advanced form of AI that can perform any intellectual task that a human being can. It's still a theoretical goal, but the thought of it is exciting, isn't it? Now, you might be wondering, how does this AI thing work? Let's dive in. AI systems function on data, and lots of it. Picture a newborn child, their brain a sponge absorbing information from the world around them. This is essentially how AI works. It learns from data, much like a child learns from experiences. The data we feed into AI comes in two flavors: structured and unstructured. Structured data is organized. Think of spreadsheets with rows and columns, where each piece of information has a designated place. It's neat, tidy, and easy for AI to digest. On the other hand, unstructured data is a bit messier. It's like a box filled with random items, text, images, videos. Although it can be more challenging for AI to process, it's also more reflective of the real world and thus incredibly valuable. Both types of data are integral in training AI systems, helping them recognize patterns, make predictions, and ultimately mimic human intelligence. With enough data, AI can start learning. But first, we need to clean and pre-process the data. Data pre-processing is like cleaning your room before a big study session. It's the step that sets the stage for the heavy lifting of AI. Imagine trying to study in a cluttered room. It's tough, right? The same goes for AI models trying to learn from messy data. In data pre-processing, we tidy up our data. We remove the noise, those random, irrelevant fluctuations in data that can lead to incorrect conclusions. Imagine trying to study with a blaring television. Noise in data is just as distracting for AI models. We also handle missing values. It's like filling in the gaps in your notes before studying for an exam. Missing values can skew the learning process, leading to less accurate predictions. And then we normalize data. It's about bringing different types of data onto a common scale, much like translating different languages into one that you understand. Once the data is clean, it's time to train the AI model. Training an AI model is like teaching a child how to ride a bike. You provide guidance, set some boundaries, and then let them try it out and learn from their mistakes. Just as a child learns to ride a bike by trying and falling, an AI model learns from data by trying and adjusting. This brings us to a concept called supervised learning, a popular type of machine learning. Picture this. You're teaching a child to recognize dogs. You show them many pictures, each labeled either dog or not dog. Over time, the child learns to distinguish dogs from other animals. That's exactly how supervised learning works. We feed the AI model a labeled dataset, which is a collection of examples with the correct answers, or labels. The model learns to map inputs, our pictures, to the correct outputs, whether it's a dog or not. Now let's dive into the core of AI training. Model training. This is where the magic happens. Remember the child learning to ride a bike? They don't get it right the first time. They wobble, they fall, they adjust and try again. Similarly, an AI model doesn't get it right immediately. It makes predictions based on the data it's seen, and initially those predictions may be way off. Here's where the model training steps in. The AI model has a set of internal parameters, kind of like the child's sense of balance and coordination. During training, these parameters are adjusted to minimize the difference between the model's predictions and the actual outputs in the training data. Imagine the child adjusting their balance and steering each time they wobble or fall. Over time, their coordination improves, and they wobble less. Similarly, as the AI model adjusts its parameters, the accuracy of its predictions improves. This process continues until the model's predictions are as close as possible to the actual outputs. It's a cycle of learning, adjusting, and improving, much like a child gradually mastering the art of bike riding. But how do we know if our AI model is ready to ride without training wheels? We test it. Testing an AI model is like giving a child a bike test after teaching them how to ride. After all, we wouldn't want our child pedaling off into the sunset without making sure they can handle the ride, would we? The same goes for AI models. Once the model has been trained, it's time to put it to the test. This testing phase is crucial to ensure that our model is ready to face real-world data. The model is exposed to a separate set of data, known as the test data set. This data set is like the training data, but it's unseen, meaning the model has never encountered it during its training phase. The model's task is to make accurate predictions based on this new data. To assess the model's performance, we use a variety of metrics. If our AI model is predicting categories, like whether an email is spam or not, we might use accuracy as a measure. If it's predicting numerical values, like the price of a house based on its features, we might use mean squared error, which tells us how close the model's predictions are to the actual values. But testing isn't just about getting high scores on these metrics. It's also about understanding whether the model can generalize well. Can it make accurate predictions on new, unseen data? Can it handle the twists and turns of real-world data, just like a child navigating a new bike path? Once the model passes the testing phase, it moves on to the prediction or inference phase. This is where the rubber really hits the road. The model is deployed and starts making predictions or decisions based on new, unseen data. It could be determining whether a transaction is fraudulent, identifying objects in an image, or even diagnosing diseases based on medical scans. So, in essence, the testing and prediction phases are about ensuring that our AI model doesn't just memorize the training data, but truly learns from it. It's about ensuring that it can navigate the complexities of the real world, making accurate and useful predictions. Now that we know how AI works, let's look at the different approaches to AI. There are several paths to reach the peak of AI mountain. Let's begin our ascent with machine learning, or ML for short. This is a major approach to AI where machines learn from experience. Imagine teaching a toddler to identify a cat. You show them pictures of cats, and each time they correctly identify a cat, you reinforce the learning. That's similar to what happens in machine learning. The machine learns from data, making predictions or decisions without being explicitly programmed to carry out the task. The more data it gets, the better it becomes at making these predictions, much like our toddler becoming a cat-identifying expert. Next on our trail up the AI mountain is deep learning. Consider this as a subset of machine learning, but with an added layer of complexity. Deep learning uses artificial neural networks with multiple layers, hence the term deep. It's like a virtual representation of the human brain, processing data in a more complex and layered way. This approach has been particularly successful in tasks such as image and speech recognition. It's the reason why your phone can identify your face or why your smart speaker understands your voice. Lastly, we reach the path of natural language processing, or NLP. This is a fascinating branch of AI that focuses on the interaction between computers and humans using our natural language. It allows machines to read, understand, interpret, and even generate human language. Imagine having a chat with your computer and it understanding and responding just like a human would. That's what NLP aims to achieve. It's the secret sauce behind your virtual assistant's ability to understand your commands or your email's ability to check your grammar. Each of these approaches, machine learning, deep learning, and natural language processing, are different paths leading us to the peak of AI development. They all play their part in shaping AI's capability to mimic human intelligence. And that, my friends, is how AI works. The future of AI is bright and full of endless possibilities. AI is not just the future, it's the present. As we stand on the precipice of a new era, the scope of AI continues to expand. Ongoing research and development are pushing the boundaries, transforming how we live, work, and connect. From healthcare to entertainment, transportation to education, AI's potential is limitless. Well, that's all the time we have for today. Please leave your comments below of what you think of this video and how AI affects you at a personal level. And do us a favor, smash that like button, and thank you for watching.